Okay, quick summary. The graph of this function is easily done. We just find the zeros and plot them. We find the y-intercept. Now, when we do that, we don't yet have the curve, but we determine that if x is much greater than 7, then all these are going to be pretty big numbers. So when we multiply them together, we get a big number times a big number times a big number, which is really big, which means the graph is going to take off this way after it passes through 7. If we go to the left of -5, well, any number less than -5 is going to make x plus 5 negative. And of course, we'll be adding a negative to a negative here and here if we use x equals -5. So we're going to get negatives here, so we're going to get 3 negatives, which is going to make the product negative. And it's going to, if we move very far beyond -5, it's going to be 3 big negatives, which is going to give us a really big negative. So the graph is going to take off this way down here. So now, knowing that it goes through this point, this point, this point, and this point, takes off upward here, takes off downward here, we can easily sketch the curve. Some people are missing the fact that if we go far to the right, we have either a humongous up or humongous down. If we go far to the left, it's either great big up or great big down. Now we're going to do a little more with this idea. We're actually going to determine that the function has to be negative to the left of -5. It has to be positive between here and here, negative between here and here, positive between here and here, just by some simple characteristics of signs. Okay, so we've got a graph here, and this graph is something we did after we did what's on the next board. So I'm going to say ignore that for the moment. And let's look at this expression. Now this is what we call a rational function. You've got a polynomial on top in factored form. You've got a polynomial on bottom in factored form. Now whether the polynomials are factored or not, you know that at least theoretically they can be factored into linear and irreducible quadratic factors. Hopefully, so you can think of the polynomial being in factored form even if it isn't. But if it is in factored form, then you can make a good attempt at drawing its graph because you can locate its zeros and vertical asymptotes that occur for this thing. Okay, so if x is, well, what are the zeros of the numerator and what are the zeros of the denominator? Those are the points that we want to start with. The zeros of the numerator are -5, 4, and -2. So you see I've got those here. Here's -5, here's 4, here's -2. And the zeros of the denominator, -3 and 7. Here's -3, here's 7. Okay, so I indicate all of those zeros on the graph. And then I determine, well, okay, the sign of q of x. Q of x can only change from positive to negative if one of the factors changes from positive to negative, or negative to positive if one of the factors goes from negative to positive. So, for example, the factor x plus 5 will change from negative to positive when x goes from less than -5 to greater than -5. If x is a little less than -5, then this is going to be a little less than 0. If x is a little greater than -5, it's going to be greater than 0. So when x is at -5, if you go from this side of -5 to this side, this factor goes from negative to positive. The other factors don't change their sign if you just go a little ways from the left of -5 to the right of -5. Okay, they all maintain their signs. Only this one changes. So this one changes sign, all the rest maintain their signs, retain their signs. Okay, so that means that the total function can only change sign in this region as it passes -5. And then it can't change sign again until you pass -3, because at -3, the sign of the x plus 3 is going to change. Then when x gets to -2, the sign of x plus 2 is going to change, and so forth. Okay. Between -5 and -3, we can easily reason out that x plus 5 is going to be positive because x is going to be more than -5. X minus 4 is going to be negative because every number between here and here is negative. X plus 2 is going to be negative because the biggest number you can add, or the greatest number you can add to -2 on this interval, would be a number just short of -3, and that would still give you a number close to -1. So for any number between -5 and -3, we can determine what the sign of each of these is. Okay? So this one will be positive, this one will be negative, this one will be negative, this one will be positive, and this one will be negative. I indicate that here. Uh-oh. Something's wrong with what I wrote down. Okay. Now this that I wrote here took me a minute to figure out what it was. But for x between -5 and -3, the reasoning of this expression here is x plus 5 is positive, x minus 4 is negative, x plus 2 is negative, and that's divided by x plus 3, which is positive, and x minus 7, which is negative. And now, okay, let's look at the -3, -2, that was right. Okay, sorry. Between -5 and -3, x plus, if x is between -5 and -3, x plus 3 is going to be positive. I was looking, somehow my eye was catching this interval when I was talking about this one. So anyhow, you can easily determine that you have a positive, a negative, a negative, a negative, a negative between -5 and -3. Now you can just reason that out of where these numbers are, okay? But if you really can't reason it out, you can say, okay, well, let's see, 4 is in here, so let's just see what this expression is if x equals 4. Well, you do that, and you determine that you multiply it out and everything is positive. Or you just look at the signs of the factors, and you see again that you have positive, negative, 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 negative. So you determine that it's positive. Now, what I'm writing down here, and you can go back and see the explanation as I did it in the original video, it's just the signs of the 5 factors on each of these intervals, so that I use those signs to determine on which intervals the function is positive and what it is negative. Okay? Now, I did make notes here. I said the sign remains constant on each of the intervals. Okay, each of the intervals from -infinity to -5, from 5 to -3, from -3 to -2, and these are open intervals because we don't include the endpoints, because at the endpoints things are 0. Okay, so we have these 5 intervals, 6 intervals. Okay, if x is a big negative number, we easily determine that q of x, this expression, is negative because all these are negative and there are 5 of them. And it's a big negative, but it's negative. Okay? If we use x equals 0, which falls in the interval from -2 to 4, and we usually do this because we usually try to find the y-intercept. Okay, if x equals 0, we get the y-intercept, and we can do that here, and we easily determine that that's positive. Since the y-intercept is above the axis, then on the interval that contains the y-intercept, the function is going to be positive. A big positive x implies that q of x is positive and 7 to infinity. Okay, big positive x makes all these positive, so when you multiply and divide them, you get just a positive. Once we have that information, I'm not sure where I went here. Okay, well, a lot of that reasoning is outlined here. Okay, so we explained this, and this is in the original video, so I'm not going to talk about it. Take the explanation I just gave, and if you don't understand that, look at this part of the video. What that tells us is that function's negative in this interval, positive, negative, positive, negative, positive. Okay, well, there's one more thing. If the denominator is 0, then you're going to get a, near the value. Okay, like, for example, the denominator is 0 at x equals -3. So if x is close to -3, this is going to be close to 0, and this isn't. Meaning you're going to be dividing a number that isn't close to 0 by one that is close to 0. Meaning you're going to get a big result. And if x gets closer to 3, to -3, the numerator doesn't change much, the denominator gets tinier and tinier, so it goes in more and more times. That gives us a vertical asymptote. So we can sketch kind of a dotted vertical line at -3 and another one at 7 to indicate that this thing approaches a vertical asymptote at -3 and at 7. Just like 1 over x approaches a vertical asymptote at the y-axis, or 1 over x squared approaches a vertical asymptote at the y-axis. 1 over x like this and then like this, okay? But you know how that works because you're familiar with the graphs. Okay, so what it's going to amount to is we have to draw a graph that's negative over here, positive over here, goes through all these zeros, and has asymptotes, vertical asymptotes at these lines. And to do that, I'm going to end up messing up this picture, but it's worth seeing. Okay, we come down from the negatives, we come up here, and we go on up to the vertical asymptote. Now, graph, it's the function is negative up to this point, positive on this interval, so it's positive here all the way up to here. It's not defined at this point. Then, on this interval, it's negative and it's got the vertical asymptote, so it's going to do this up to here. And then, well, I tried to make that, I obliterated that negative, and then I messed it up. Chalk kind of slipped. Okay, so we're negative on this interval, and we got the asymptotes, we do this. Then it's positive on this interval. It's got to get back to 0 here, so it's probably just going to, hump up somehow and come back down, maybe a little higher, but I didn't want to hit that plus sign. And then it's negative and approaches this vertical asymptote, so it's going to come on down like this. On the other side of this vertical asymptote, it's positive, so it's got to start out down like this, but it's got to go to positive values, and the positive values are going to be large, so it's going to have to turn around and go off like this. And that's what you see here. I gave the same explanation when I did this. And that graph looks a whole lot like this one, has the same most important characteristics. Okay? So there we have it. We also talked about the properties of inverse functions. And I'm not going to go over that briefly. It's an introduction. You want to look at this on the actual videos if you don't understand it. I'm going to leave it at this because this brief summary is getting non-brief.